number 21. We have f of x equal to x to the sixth minus 2x to the fourth minus 3x squared. We can get a common factor of x squared out of these three terms, so let's do that. Factor out the x squared. That leaves x to the fourth minus a 2x squared minus 3. Alright, set that equal to 0. And then that means this equals 0, this factor, or this factor equals 0. So x squared equals 0, or x to the fourth minus 2x squared minus 3 equals 0. Alright, so this is pretty easy to solve. X equals 0. And over here, this is reducible to a quadratic equation. So we'll let u equal x squared. So then that would be u squared squared, right? Or rather, x squared squared, not u squared squared. This would be x squared squared is x to the fourth. Let me write it up here in case you're not seeing that. Alright, this would be your u, which equals x squared. Alright, so that would be down here, u squared. And then minus 2u minus 3 equals 0. So this can be factored. U plus 1 times u minus 3 equals 0. So that means u plus 1 equals 0, or u minus 3 equals 0. And so that means u equals -1 on this one. And now we have to go back to x's, right? So u equals x squared. So x squared equals -1. Now, this does not have any real number solutions, right? You can get into the complex numbers using imaginary numbers and get an answer to this, but we're not dealing with that. So there's no solution for this. So I'll put the empty set symbol there for no solution. No real solution, that is. And then on this one, u equals 3. So now u equals x squared, so x squared equals 3. And then you take the square root of both sides, and you get plus or minus square root of 3 for x. So again, when you take the square root of both sides on an equation like this, don't forget there's a negative square root as well as a positive square root. Alright, so we've got three solutions: 0, square root of 3, and negative square root of 3. Alright, so 0, 0 is one of the intercepts, x-intercepts. Square root of 3 is 0, and negative square root of 3 is 0. Okay, number 23. So we have f of x equals x to the fifth minus 5x cubed plus 4x. We can get a common factor of x out of this, so let's common factor the x out, and we get x to the 4th minus 5x squared plus 4. So you set that equal to 0. And then that means the x equals 0, or this factor here equals 0. X to the 4th minus 5x squared plus 4 equals 0. Well, that's already solved for us. How convenient. On this one, we have to do a little work, unfortunately. Oh well. So let's go ahead. We can let u equal x squared. And now we've got u squared minus 5u plus 4 equals 0. And then this can be factored. U minus 1 times u minus 4 equals 0. So that means u minus 1 equals 0, or u minus 4 equals 0, and so u equals 1. What's u? It's x squared, so x squared equals 1. And you take the, you can subtract 1 from both sides, or you can take the square root of both sides. Let's subtract 1 from both sides. X squared minus 1 equals 0. And this is a difference of squares. X plus 1 times x minus 1 equals 0. So x equals, or x plus 1 equals 0, or x minus 1 equals 0. Alright? And so x equals negative 1, or x equals 1. Alright? You can also take the square root of both sides there, and you would get x equals plus or minus square root of 1, which is just plus or minus 1. Alright? So here you just add 4 to both sides, you get u equals 4, and that means x squared equals 4. And you can also subtract 4 from both sides. X squared minus 4 equals 0, or you could take the square root of both sides. And this is the difference of squares again. X plus 2, x minus 2 equals 0. It's always good to know more than one way to do these, because sometimes one way might not work, whereas another way would. Alright, so it always helps to know more than one way. So x plus 2 equals 0, or x minus 2 equals 0. And so x equals negative 2, or x equals 2. Alright, so we have all of these. We've got 5 different solutions here. We got zeros, or 5 different intercepts, x-intercepts. 0, 0, negative 1, 0, 1, 0, and negative 2, 0, and 2, 0. Number 25. For the following exercises, use the intermediate value theorem to confirm that the given polynomial has at least one zero within the given interval. So look at the IVT, intermediate value theorem, again on page 249. It says, let f be a polynomial function. So this will work for polynomial functions, alright? The intermediate value theorem states that if f of a and f of b have opposite signs, then there exists at least one value c between a and b for which f of c equals 0. So let's take a look at this function here. This is a polynomial f of x is x cubed minus 9x. And we want to find a value between these 2 points here, x equals 2 and x equals 4, for which f of that value will equal 0. Alright, so, well, what is f of 2? Plug in x equals 2. Alright, you get negative 10. Now I'm hoping f of 4 here is going to be positive. Alright, this is negative, f of 2 is negative. F of 4 I'm hoping is positive. If it is, then we can use the IVT and do what they want us to do. Alright, so let's look at f of 4. That equals 28. So, and that's just what I was hoping. In the IVT, alright, A is equal to 2 on this one, in this example, and B equals 4. And I'm referring to the A and B that are mentioned in the theorem, alright? And f of 2, that's f of a in the theorem, is negative 10, and f of b, or f of 4, is positive 28. So f of a and f of b have opposite signs. Okay, so what does the theorem say? Okay, if f of a and f of b have opposite signs, then therefore there exists, that backward capital E means there exists at least one value c between A and B. For which f of c equals 0. So the IVT guarantees at least one value c between a, which is 2, and b, which is 4, for which f of c equals 0. Alright. Now, what is that value c? Well, the IVT doesn't tell us what it is. All it tells us is it exists, there's at least one value, and it's going to be between these two values here, between x equals 2 and x equals 4. That's all the IVT guarantees us, alright? So, so if you kind of do a rough sketch of the graph here, if this is x equals 2, and x equals 4. F of 2 is below the x-axis, down here at negative 10. Let's just call that negative 10. And I'm running out of space, so I'm going to make this really a bad sketch. F of 4 is positive 28, so it's up here. It's above the x-axis. So the intermediate value theorem tells us that somewhere, in order for the function f to get from here below the x-axis to here above the x-axis, it has to cross the x-axis in at least one point somewhere between 2 and 4. Okay, now, like, I don't know how exactly it'll look or where exactly it'll be in here, but it's got to go there somewhere between 2 and 4. What if it does something like this, you might ask? What if it does this? Kind of curves around, but outside of one of these two numbers. Well, then it fails the vertical line test if it bends around somewhere. All right, and it's no longer a function. And we all know that polynomials are functions. All right, so it's not going to do that. It won't do that. So, yeah, it's got to cross somewhere. Now, again, we don't know exactly where it is. Okay, and we don't know exactly how many times it crosses over. Right? It could do something like this. It could go like that, maybe. We don't know exactly what'll happen. All right. Well, we could find out pretty easily. But what I'm saying is, in terms of the IVT doesn't guarantee against this happening. All right. It just tells us that it will cross at least one time. All right. Across the x-axis there, and there's where you're going to have your 0. Right there, wherever that C is there. Number 27. We have f of x equal to negative x to the 4th plus 4. And we want it to be, we want to find, or we want to know if there's a root between x equals 1 and x equals 3. So, again, you take f of 1 and take f of 3 and hope they are of opposite signs. Okay, f of 1, what is f of 1? Plug in x equals 1 and you get 3. And f of 3, what's that? Hopefully it's negative. Yeah, it is, negative 77. Okay? So, since f of a and f of b, where a equals 1, b equals 3, f of a and f of b are of opposite signs, the IVT guarantees there's at least one value between 1 and 3. So x is there's some value x between 1 and 3 for which f of that value is 0. All right? That's guaranteed by the intermediate value theorem. Number 29. F of x is equal to x cubed minus 100x plus 2. And we want to see if there's a value between x equals 0.01 and 0.1 for which f of that value equals 0. Alright, so take f of 0.01, plug it in, you get 1.0000001. And f of 0.1. We're looking for a negative result and we get it, negative 7.999. Alright. So because we have a sign change between f of a and f of b, the IVT guarantees that there is a value between these two for which f of that value is equal to 0. Number 31. For the following exercises, find the zeros and give the multiplicity of each. Alright, so we have f of x is equal to x squared times the quantity 2x plus 5, or not 2x plus 5, 2x plus 3 rather, to the fifth, and then x minus 4 quantity squared. Alright, so you set that equal to 0. And so that means x squared equals 0. So x equals 0. And, or we have 2x plus 3 to the fifth equal to 0. And you could take the fifth root of both sides, so 2x plus 3 equals 0. 2x equals negative 3, and x equals negative 3 halves. So since this is an odd power, when you take the odd root of both sides, you don't have to worry about plus or minus. Okay, so for example, the cube root of, or rather 2 cubed equals 8. So the cube root of 8 is equal to 2. There's no negative 2 there because negative 2 cubed is negative 8. Alright, so with odd roots you don't have to worry about the plus or minus. Okay, and over here we've got or x minus 4 quantity squared equals 0, and that means x minus 4 must equal 0, and so x equals 4. Alright. Okay. So since we have a power 2 here, x squared equals 0, that means we have a root 0, multiplicity 2. The small m I'm taking to mean multiplicity. Alright, and then we have negative 3 halves, and since we have a raised to the fifth, that would be multiplicity 5. And then we have 4, multiplicity 2 from that square there. Number 33, we have f of x is equal to x squared times the quantity x squared plus 4x plus 4. Okay, and this can be written as x plus 2 quantity squared. Alright, that's a perfect square trinomial. Alright, so set this function equal to 0. So x squared equals 0, or the quantity x plus 2 squared equals 0. Alright, so x equals 0, and or rather x plus 2 must equal 0, and so x equals negative 2. Alright, so we have a 0 multiplicity 2, that's from that power 2, and we have negative 2 multiplicity 2. Number 35. We have f of x equal to 3x plus 2, the quantity, raised to the 5th power, times the quantity x squared minus 10x plus 25. Now I suspect this can be factored, and it can be. Right, so this is 3x plus 2 quantity raised to the 5th, and then x minus 5 quantity squared. So you set this equal to 0. Which means that a 3x plus 2 quantity to the 5th equals 0, or x minus 5 quantity squared equals 0. And so 3x plus 2 equals 0, and 3x equals negative 2. So x equals negative 2/3. And the multiplicity on this would be 5, m5. And here we've got x minus 5 must equal 0, so x equals 5, and the multiplicity is 2. Number 37. F of x equals x to the 6th minus x to the 5, x to the 5th, minus 2x to the 4th. So we can get a common factor of x to the 4th out of these three terms, so we'll do that. And that's x to the 4th times the quantity x squared minus x minus 2. Now factor that if you can, and you can here. Alright, so that would be x plus 1, x minus 2. Okay, now set all that equal to 0. So that means x to the 4th equals 0, or x plus 1 equals 0, or x minus 2 equals 0. Okay, so x equals 0. So we have 0 multiplicity 4 as one answer. Alright, the 4 comes from that power 4 on the x there. Alright, and then we've got x equals negative 1. So negative 1 multiplicity 1, there's a power 1 there, you can assume. There's a power 1 there. Because there's nothing there doesn't mean that's 0. Alright. Maybe some people might be tempted to think that. Alright, there's nothing there, so that must be a 0. No, it's 1. If it were 0, the whole thing would be equal. This whole factor would be equal to 1. Alright, so anyway, it's a 1. So that's multiplicity 1, and then x equals 2. So that's 2 multiplicity, again, 1, because of that power 1 there. Okay, which maybe you can't see, but you put on your special rose-colored math glasses, and they appear magically. Number 39. We have f of x equals 4x to the 5th minus 12x to the 4th plus 9x cubed So we can factor a common factor of x cubed out of these three terms. That leaves us with 4x squared minus 12x plus 9. And this right-hand factor can be factored. So that's the x cubed, and then you've got a 2x minus 3 quantity squared. So you set all that equal to 0. So that means x cubed equals 0, or quantity 2x minus 3 squared equals 0. So that means x equals 0, and that's 0 is multiplicity 3. That comes from that cube there. And then we've got 2x minus 3 equals 0, and 2x equals 3, and x equals 3 over 2. So we have 3 over 2, 3 halves, with a multiplicity of 2 from that power 2 there. (41). We have f of x equals 4x to the 4th times quantity 9x to the 4th minus 12x cubed plus 4x squared. And we can get an x squared out of these three here. So we have 4x to the 4th. I'll put that in parentheses in front. Factor out the x squared, put it right next door. And then we've got 9x squared minus 12x plus 4, like that. And now we've got x to the 4th times x squared is x to the 4 plus 2, right? X to the 6th. So this is 4x to the 6th, and then 9x squared. Well, actually, I can factor that last factor there, which I will do. So that's 3x minus 2 quantity squared. Alright, now you set that equal to 0. Oops. I'm getting a little bit ahead of myself here. I want to get done with this problem, right? Because this is the last one of these kind of problems. Alright. I think you all understand my feeling here. Okay. So that's equal to 0. Yeah, mathematicians sometimes get bored with certain problems, okay? But anyway, not everybody's bored, so, and people are learning, so that's good. That's what counts. So it doesn't matter how I feel. What matters is that you get what you need out of this. Alright, so you can divide both sides by 4, so you get x to the 6th equals 0. You could do that if you want to. And then x equals 0, so you have 0 multiplicity 6 from that power 6. Alright, and 3x minus 2 equals 0. 3x equals 2, and x equals 2/3. So that's 2/3. And that's multiplicity of 2 from that power 2. Okay.